In this video, I'll consider decimal to binary conversion and binary to decimal conversion. In my previous video, already we have studied different number system. Now in this video, let's study how to convert a given decimal number into binary and given binary number into decimal. Let me consider one example. So I will take the same example, that is, let the decimal number is 21. The decimal number in decimal number system is represented like this: 21, this 10. 10 indicates the base of decimal number system, which is 10. So this needs to be converted into binary. What is binary equivalent of this? I'll show you the process to convert decimal number into binary. Write the decimal number 21 like this. Now we need to divide this 21 by the base of binary number system, that is 2. This is base of binary number system, that is 2. So if we divide 21 by 2, the quotient will be 10 here and the remainder will be 1. Write the remainder here like this. Then again this 10 will be divided by 2. That is, divide this 10 by 2. It will be 5. The quotient will be 5. Remainder will be 0. Again this 5 should be divided by 2. That is 5. Quotient will be 2. That is 2 into 2, 4. The remainder will be 1 like this. Again divide 2 by 2, so that is it is 1. Quotient remainder will be 0. So after getting 1, we should stop the process because further division by 2 is not possible. Once this process is done, now we need to represent these remainders right from here in bottom to up fashion. That is, in this order we need to write these numbers. Therefore I can write 1 0 1 0 1, that is 1 0 1 0 1 1 0 1. So this is the binary representation of given number 21. So therefore 21, which is in decimal, is equal to 10101 in binary. Now let me take one more example. I will take the number 41. So 41 is a decimal number. What is binary equivalent of this? So now we need to divide this 41 by 2 repeatedly like this. So divide 41 by 2, that is we have 20, because 20 into 2 is 40. Remainder will be 1 right here. Again divide this 20 by 2. Quotient will be 10. Remainder will be 0 right here. Now we have 10. Divide 10 by 2. It will be, quotient will be 5. Remainder will be 0. Again divide 5 by 2. That is 2 into 2, 4. Remainder will be 1. Then we have finally again divide this 2 by 2. It will be 1. Remainder will be 0. Once we got 1 here, we need to stop the process. Now we need to write these numbers and remainders in bottom to up fashion. That is, in this order we need to write. That is 1 0 1 0 0 1. Therefore 41, which is in decimal, is equal to 1 0. We have 1001 1001. So this is a binary equivalent of the decimal number 41. Let me consider one more number, say 127. It is in decimal. What is binary equivalent of this? I'll consider 127. Divide this 127 by 2. So this will be 2 6 12. Then we have 7. 7 by 2 will be 3. Remainder will be 1. Similarly, divide 63 by 2. It will be 3 1. Remainder will be 1. Similarly, again divide this 31. That is 2 into 15 is 30. Remainder is 1. Divide 15 by 2. That will be 7. Remainder is 1. Again divide 7. That is 2 3 is 6. We have remainder is 1. Then 2 1 is 2. Remainder will be 1. So once we got 1 here, we should stop the process. Now write these numbers in bottom to up fashion. That is, we have 1 1 1 1, then 1 1 1. That is 1 1 1. So this is the binary equivalent of the given decimal number 127. So now let me consider the fraction numbers. Like if the decimal number is say 87.5, which is in decimal, so what is binary equivalent of this? So in this, first let me take the full number, that is 87. Consider 87 first. So I'll take 87, divide 87 by 2 repeatedly, that is we have 2 4s are 8, and here we have 7 by 2, that is 2 3s are 6, remainder will be 1. Divide 43 by 2, we have 2 2s are 4, and this will be 2 1s are 1, remainder will be 1. 21 by 2, it will be 10, remainder will be 1. Then we have 10 by 2, that is 5, remainder will be 0. We have 2, 2 to the 4, remainder will be 1. Then finally 2 by 2 is 1, remainder is 0. So this 87 in decimal is equal to 1010, that is 1010 111 111. This is the binary equivalent of 87. So along with this we have 0.5. So let me consider the fraction part. So this 0.5, 0.5 is nothing but 0.5. So to convert this 0.5 into binary, we have to multiply this 0.5 repeatedly by 2. That is, I'll multiply this 0.5 into 2. So I will get 0.5 into 2, that will be 0.5 into 2, it will become 1.0. So once if we got 0 here, we have to stop the process. So now I'll tell you how to combine these two. That is, now I can write 87.5 binary 10 will be equal to, this is the first number, that is 1010111 point. Here we have decimal point. So here it will be, we have to consider only this number, that is 0.1. So this is the binary equivalent of 87.5. Now let me take one more example. Suppose the decimal number is say 0.6875, which is in decimal. We need to find the binary equivalent of this. So as I said, this is a fraction number. We have to multiply this number by 2 repeatedly. That is, I will represent it as, first let me take the number 0.6875 into 2. So if we multiply, the result will be 1.3750. So here 1 is integer part, 0.3750 is fraction part. Now let me write this 1 here. I will write 1 here. Now consider only fraction part again, that is 0.3750. Again multiply this by 2. So we will get 0.7500. Now we have to write this part, integer part here, that is 0. Now I'll take only fraction part again, that is 0.7500. Multiply this with 2, we will get 1.5000. So here this is the integer part right here. Now again take the fraction part, that is 0.5000 into 2. Now the result will be 1.0000. So this integer part should be written here. So finally if we multiply this 0 with 2, again we will get the 0. So we should stop the process. So therefore now I can write 0.6875, which is in decimal. The binary equivalent of this is 0. It should be given 0. These values should be written from top to bottom order, that is in reverse. 1011, that is 0.1011, which is in binary. Now let me consider the reverse operation, that is binary to decimal conversion. Let me consider the binary number, say 10101. Consider this as a binary number. What is decimal equivalent of this? One binary number is 1 0 1 0 1. So by default here we have a decimal point. The position values varies from 0, that is this is 0th position, this is second number is first position, second position, third position, and this is fourth position. Now I can represent it as, start from this number, we have 1 into the base of binary number system is 2 power position number, that is 4. Similarly plus next number is 0, that is 0 into base is 2, power will be 3, like this. Plus next number is 1, that is 1 into 2 power 2, plus we have next number is 0, 0 into 2 power 1, and this is 1, that is plus 1 into 2 power 0. Let me simplify this. This is 16, this will be 0, plus this will be 4, this will be 0, and this will be 1. So if you do this operation, 16 plus 4 plus 1, which is nothing but 21. So this 21 is in decimal. So therefore we can write 10101, which is in binary. The equivalent decimal number is 21. Let me take another example. Let the binary number is 110101, which is in binary. What is decimal equivalent of this? Let me write the binary number 110101. So here the decimal point will be here. The position numbers, that is this is 0 1 2 3 4, and this is 5. So I can write it as, first write this number, that is 1 into 2 power position, that is 5. Similarly next number is 1 into 2 power 4, plus next number is 0, 0 into 2 power 3, plus next number is 1, that is 1 into 2 power 2, plus next number is 0, that is 0 into 2 power 1, next is 1, that is 1 into 2 power 0. Let me simplify. 2 power 5 is 32, plus 2 power 4 is 16. This value will be 0, plus this value will be 4, plus this will be 0, plus 1, that is this will be, summing this will get 53. Therefore 110101, which is in binary, the equivalent decimal value is 53. Let me consider fraction binary number, that is 1101.11, which is in binary. What is decimal equivalent of this? Let me consider the number. Given binary number is 1101.11. So this can be represented as, so here we have a decimal point. Left to the decimal point, position numbers varies from 0 1 2 3. Right to the decimal point, it will be -1 -2, like this. So let me start from here, that is 1 into 2, base is 2, 2 power 3, plus here we have next number is 1 into 2 power 2, plus next number is 0, that is 0 into 2 power 1, next one is 1, that is 1 into 2 power 0, plus after decimal point the first number is 1, write it as it is, 1 into 2 power, we have to write -1, plus 1 into 2 power -2. Let me simplify. This is 8, this is 4, plus 0, plus 1, plus 2 power -1 means 1 over 2 power 1, plus 1 into 2 power -2 means 1 over 2 power 2. So this is nothing but this is 12. So this is 8 plus 4 plus 1 is 13, plus 1 by 2 means 0.5, plus 1 by 2 power 2, that is 1 by 4, that is 0.25, which is nothing but 13.75, which is in decimal. Let me consider the last example. Say 1110.1011. Let me convert this into by decimal. So the given number is 1110.1011. So here we can see that Here we have decimal point. The position value is 0, 1, 2, 3, and here it is -1, -2, -3, and -4. So I can write, I can start from here. 1 into 2 power 3 plus next number is 1 into 2 power 2 plus 1 into 2 power 1 plus 0 into 2 power 0 plus after decimal point first number is 1 into 2 power -1 plus 0 into 2 power -2 plus 1 into 2 power -3 plus 1 into 2 power -4. I can simplify this. This is 8 plus 4 plus 2 plus this will be 0 plus this is 1 over 2 power 1 plus this is 0 plus 1 over 2 power 3 plus 1 over 2 power 4. So simplifying this, I can write this is 8 plus 4 plus 2, that is 14, plus 1 over 2 means 0.5 plus 1 over 8 means 0.125 plus 1 over 16 means 0.0625. So simplifying this, we will get 14.6875. So this is decimal equivalent of given binary number 1110.101. So in my next video, I will consider decimal to octal and octal to decimal conversion. Thank you for watching.